Hey Year 10, welcome to exercise 3C, where we're going to be talking about mutually and non-mutually exclusive events linked to the topic of probability. So let's get into it. First of all, we need to understand what mutually exclusive and non-mutually exclusive things are. Mutually exclusive events, they've got nothing in common. So notice when I draw the two circles, there is no overlap because there can be nothing shared between them. Here's an example of two different things. A could represent when you flip a coin. You're going to heads or tails. B could represent rolling a die. You can get a 1, 2, 3, 4, 5 or 6. Do they have anything in common in all? No, they don't. So if I was actually marking them on a circle, there'd be heads, tails in that one. 1, 2, 3, 4, 5 and 6 would go in that one. And there's no overlap because they have nothing in common. And we have a formula that we can use. When you want to find what is in A or B, you just find what's in A, you just find what's in B, and you add those two answers together when you're dealing with probabilities. If we're interested in what's in A and B in both circles at the same time, nothing is in both of them. When you're talking about non-mutually exclusive events, that means they do have something in common. So for example, let's say I had a deck of cards and I said pick a card, any card. And you picked a card. When I then go back and look to see what's there, when I ask you to pick a second card, you've got to be careful because you can't pick the same card twice. So let's try some examples and see how we go. We're going to select a card, and I've put the deck of cards there so we can see them. For anyone that don't know what a deck of cards looks like, you need to actually be able to tell what the suits are and what the colours are and all of that sort of stuff to answer these questions. So we're talking about two different things. We're going to talk about Group A or Set A, and that's getting a club. And you can see all the clubs in my first row here. We're going to talk about Set B or Group B. That's getting an ace. And there are my aces there. So, part A says, first up, to find the number of cards that are in Group A. What's Group A? It's a club. So this is a fancy way of saying how many clubs are there in a deck of cards. If you come up here and count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's the easiest way to answer that question, to look at the picture. Or to know there's 52 in a deck of cards, 52 cards in a deck of playing cards, and a quarter of them are clubs, and a quarter of 52 is 13. Then you don't even need to look at the picture. Part 2 says the number of cards in Group B. Now remember, Group B is getting an ace. So this is really a fancy way of saying how many aces are there? 1, 2, 3, 4. There's our answer. Part 3 says the number of cards that are not in Group A. In other words, they are not clubs. If they're not clubs, that means they can't be any of these cards. They must be in this row, or this row. And if each row has 13 cards, 3 lots of 13 is 39. So there are 39 cards that are not clubs. The next one says, find the number of cards that are in Group A and. Remember that symbol means and. So they're in Group A and they're in Group B. So they are clubs and they are aces. Well, there is only one card that is a club that is also an ace, and that's the ace of clubs. So there's only one card that is in that category. The next one says to find the probability, so not the number, but the probability of selecting a card that is in Group A. Well, Group A is the clubs. There are 13 clubs. We actually said that up here. So what's the chance or the probability of selecting a card that is a club? That's what that is saying, because Group A is a club. the chance of getting a club, you've got 13 chances out of 52 because there are 52 cards altogether, and 13 out of 52 cancels to a quarter, which makes sense because when you look at a deck of cards, 1/4 of them, one row out of the 4, are clubs. The second question says, what's the probability that you get a card that's in Group B? Remember, Group B is an ace. So what's the probability of getting an ace? There are 4 aces out of the 52 cards, which cancels to 1 chance out of 13. What's the chance or the probability of getting a card that is not in Group A? That means it's not a club. We've already said there are 39 cards that are not clubs, so 39 chances out of 52, or 3/4. And part 4, what's the chance of getting a card that is in Group A and in Group B? So in Group A, that's a club, there's 13 of them, and it's in Group B, that's an ace. Well, there's 13 cards. Oh, this is going to be a bit trickier. Let's have a look. It's got to be 13 and it's got to be an ace. There's only one of them. It's like what we said here, remember? There's only one card that is a club and an ace out of the 52. So you've got one chance in 52 of getting that particular card. Part C says, what's the probability of getting a card that is in Group A or Group B? So what's Group A? That's a club. So it's a club or it's an ace. Well, how many clubs are there? 13 of them. How many aces are there? 4 of them. But if I look at that, you'll notice something. This one I've counted twice. So we've got to be very careful. And that's why we have a formula. We say when you want to find how many cards are in A or B, find out how many are in A. Well, there's 13, so the chances of getting it a card is 13 out of 52 plus B represents aces. There are 4 aces out of 52 minus how many cards are in both. And we've already said there's 1 that's in both, 1 out of 52. It actually makes a lot of sense to use the formula when you're familiar with it, but if you actually just break it down and said how many cards are, oh sorry, I keep saying how many cards. What is the chance or the probability of getting a card that is a club or an ace? You just look at it and go, there's 13 clubs, there are 4 aces, but you can't count that one twice, so 13 and 4 are 17. Don't count that one twice, there's 16 chances out of 52, which cancels to 4 in 13. Let's find the probability that the card is an ace or not a club. That's what this means, that it is not in Group A, so it's not a club, or it's in Group B, which is an ace. So it's not a club, or it's an ace. How many cards are there that are not clubs, or they are aces? Well, there are 39 cards that are not clubs. There are 4 cards that are aces. 39 plus 4, but I've used 3 of those cards twice. 39 and 4 make 43. 43 take 3 is 40. Let's see what happens when we write our formula out. It's easier when you don't use the formula. So we're looking at probability of getting a card that is not a club. Or not a club, 39 chances out of 52, plus probability that a card is an ace, 4 chances out of 52, minus the probability that a card is not a club and it is an ace. So it's not a club and it's an ace. There's 3 of them that are not clubs and aces, so 3 out of 52. And so when you add that up, you get 40 chances out of 52. And remember, that's where my 40 comes from. I just had to put it over 52, which cancels to 10 out of 13. So they're quite tricky. It's a matter of practice with these ones. Let's have a look at example 2. Now these ones will appear typically in the tests every year. Let's see how this goes. If I look at this particular question, it says, find the probability of A intersection B. Now we know the formula is this. But it could also be this. So when you look at the two formulas, the only difference is the positioning. Both formulas are correct. So if I actually look at my statement there, I can use either formula, and I'll just write that down there for you. So when you want to find the probability of A intersection B, you can use this formula here. What's the probability of A? It's 0.4, so we put 0.4 there. What's the probability of B? It's 0.6, so we put 0.6 there. What's the probability of A union B? It's 0.85, so we put 0.85 there, and we put that into the calculator, and there's our answer. There is another way to do it, and I actually like doing it this way normally, and then you don't have to use the formula. But this is a bit more complicated for some people. There's circle A, there's circle B, and that's by figuring out everything in circle A and B has to add up to 0.85. So that number, and that number have to add up to 0.85. But circle B adds up to 0.6. And when you think about it, 0.6 and 0.25, when you plus them, give you 0.85. That means 0.25 goes in there. Because the B circle adds up to 0.6. So this circle adds up to 0.6. There's my 0.25, 0.6 and 0.25 add up to give me my 0.85. When I look inside the A circle now, I can see I've got a 0.25 and it needs to add up to 0.4. 0.25 and 0.15 add up to 0.4. 25 and 15 add up to 40. So 0.25 and 0.15 add up to 0.40. Now I can look inside circle B. I know circle B has to add up to 0.6. Do 0.6 minus 0.15 and you'll get 0.45. Add those up and they add up to 0.85. They always have to add up to 1 for probability questions, which means there's 0.15 outside of the circle. This question here now says, find the probability of A and B. Well, A and B occurs in the overlap section, and there it is there. There's the answer. Once you've got the Venn diagram drawn, you can get the answer straight up. So let's have a look at this next one. This next one, I'm going to just get a little bit tricky here. Let's clear all of it. And I'll just rewrite what I had there. I'll put it up here. I had 0.15, I had 0.45, I had 0.25, and I had 0.15 there. This question says, find the probability that it is not in A and it's not in B. Well, let's talk about not being in circle A. Where's circle A? Remember, that was circle A and that was circle B. If it's not in circle A, that means it's outside of circle A. This is everything not in circle A. So it's outside of circle A. What's not in circle B? That's that one there. What's not in circle B? Well, that would be everything outside of circle B. And this is everything outside of circle B. Now the question says, and this is messy to look at, but it's saying, what's the chance that you'd have something that's not in circle A and it's not in circle B? Well, if you look closely, you can see around the outside, I've got blue lines and green lines because that's not in circle A and it's not in circle B. It can't be in either. And that's what this diagram here is representing. Everything that's not in circle A and it's not in circle B. And when I look at what number's not in circle A and not in circle B, it's hard to read there because it's crossed out, but it's 0.15 as well. So that's the answer, 0.15. A little bit trickier. This 1 minus 0.85 means if it's not in circle A and it's not in circle B, it's 1 minus everything inside circle A and circle B, which is that number there. Easy to recognize, but sometimes when the dashes are in different positions, that method won't work. That's quite tricky, and we'll have to go through that when I get a chance when I get back. But now time to try doing some questions. So have fun and good luck. Bye for now.